Good day, ladies and gentlemen. This is the beginning of a new series of presentations describing the use of the RM software for filter design. In this part, the point will be to describe the way of use of this software and the results which may be obtained, starting with the design requirements and ending with schematics and simulation. The very first part of this second series is design of a selective polynomial Chebyshev type 1 filter. This is the content of this presentation. We will describe how the project is named, then how the design requirements are introduced, which will allow to proceed to synthesis of the transfer function of this filter. Having it, we will proceed to analysis of the properties of the solution, including comparing the results obtained with the design requirements, and then we will proceed to pass to realization in different forms, such as passive LC realization, active RC and SC realization, and digital infinite impulse response realization. We will proceed now with the synthesis of a Chebyshev filter. To start with, we double-click to the icon of the main program, RM1HTML. First, what we have to do is to allow blocked content, which is done by Internet Explorer. And then before the very starting designing, we will visit the scheme representing the recommended design sequences in order to establish a sequence. It will be first we will enter project name, then we will enter the design requirements, and then we will proceed to synthesis of the transfer function of a polynomial Chebyshev filter, which will allow to perform schematic synthesis or physical synthesis by one or by all of these programs. By the way, we may analyze the properties of the transfer function obtained by use of the program LP analysis. Now we may proceed with the design. Input the design requirements. The first requirement is the project name, which is compulsory. And we will name it Chebyshev 1. It is a low-pass filter, and so we will input the requirements. The cutoff frequency we will choose to be 100 kilohertz. The upper frequency of the transition band to be 150 kilohertz. The passband attenuation to be 1 decibel. The minimum stop band attenuation to be 40 decibels. The minimum asymptotic slow is a requirement which is specific to the RM software, and it will be implemented when rational functions are used for approximation, and because of that we are using here the minimum value of 6 decibel per octave. Then we will enter the group delay error, which will be useful when phase correctors are designed. And finally, for passive implementation, for passive realizations, we need the normalization resistance, which is here chosen to be 1 kilo ohm. This ends the process, and now we may proceed with transfer function synthesis of a polynomial Chebyshev filter. First, we need to give the order of the filter. According to the requirements, the program calculates that 7th order filter is needed, and we will accept that. So we produced the complete set of input data for synthesis of the filter, of the transfer function of the filter. This is done here. Now we may proceed in two ways to see all the output files which were produced by the program for synthesis of a transfer function, which contains an Excel file which may be used for drawings, or to make a complete analysis of the transfer function of the low-pass filter, which will produce not only frequency but also time domain results. Here are the results, and we will look for the Excel file created by the program for transfer function analysis. This part is related to the time domain response, and we will make a drawing containing the time domain response. So, by the way, we may see that the Chebyshev filter, or filter which have lobes at lower frequencies, have a very large undershoot which narrows the eye diagram when implemented in pulse transmission. Then we will go for the frequency domains analysis. And we will get here the 4 diagrams, and in order to see different solutions, we will make copies. Now, the attenuation characteristic is here. We will accommodate a little bit the scale from 0 decibel to 60 decibels only, and from 0 frequency to 150 kilohertz, and that is the attenuation characteristic, which is partly covered by the gain. Here is the attenuation characteristic. As you can see, here is 10 and this is 1. Now we will go for the phase characteristic. Not very frequently this ability can be found in softwares for filter design. And this is the phase characteristic, and now we will go for the group delay. By the way, here we have the gain, and this is the group delay. This ends the study of the response graphical study. Now we will go for analysis of the data given, for example, in this HTML file, which is a report. And we can see here different information about the response, apart from the table containing the response, among which is this number, which says that the solution of seventh order filter has slightly broader transition region than requested. We asked for 150 kilohertz, and this is 156, which means we were supposed to go with 8th order filter, which may be done again. And here are the properties in the frequency and time domain, delay time, and so on, rise time, and so on. Now we will proceed with transfer function synthesis, and first we will do Cascade low pass passive LC synthesis. The results are given in 3 files. First we will look for the SPICE file, which is best to be seen because it will produce the frequency response, and if it is good, then there is make any sense to look to the rest of the files. And as you can see, the response is fantastic, 100 kilohertz. We may go here to reduce this scale, and this is 1 decibel of passband attenuation, and so on and so on. It is of interest to have the group delay to see the shape, which is of course the same as it was in the previous diagram, where a linear scale was used. So this is the shape we had in the previous diagram. If so, we may look to the HTML file, which contains the schematic. Here is the schematic. The first element is parallel capacitor, then series inductor, parallel capacitors, and so on, until the end, which is exactly 1 kilo the resistor. This is the passive synthesis. Now we will go for Cascade RC synthesis of the same filter. And here is the SPICE file, RCC, open with SPICE. And again, of course, have the same diagram. Here is the schematic. Here is the schematic. Used as a final results. These are second order cells, 1, 2, 3, and first order cell, followed by an inverter to accommodate to the sign. The numerical values of the elements are shown here in kilo ohms. Current table. Then we will go for parallel RC synthesis. Now here is the RC parallel spice file. And the result is the same, of course. And now we will look to the schematic of the parallel realization. It is 3 second order cells, 1 first order cell, and the summing circuit where the inverters are separately shown. Next, we will go for switched capacitor realization, which first asks for a sampling frequency, which is here chosen to be 10 MHz, so-called oversampling, and the normalization or standard capacitance is chosen here to be 10 picofarads. Thanks to that, we may proceed with the synthesis. And here is the report produces SPICE file, but unfortunately it is a SPICE file with SCP for time domain simulation, which means that it will take a long time. So we will look only for the schematic of the switched capacitor filter, second order cell, second order, first order cell, and summing with inverters shown. This is the complete schematic of the system, including the sample and hold circuit, which is also shown here. Finally, we will go for a digital infinite impulse response synthesis. It asks for sampling frequency, which is again 10 MHz. And here is the result. Of course, in this case, we have no SPICE simulation, but what we have is looking to the final results, is a CSV file which contains the response, and we will make a proper drawing. And you can see that it is the very same. For example, I will try now to produce the group delay, which is the last and which allows for, this is the group delay characteristic. before we finish, we may go back now to start design, and which means that we may introduce a larger order of the filter and finish the design process with a solution which fulfills all the requirements. Thank you very much for your attention.